welcome back to my channel, and today we are going to solve the problem maximum subarray sum. This is a very popular problem also known as Kadane's algorithm. Also, this forms a basis for a lot of other DSA problems and it has a great intuition. So without wasting any more time, let's get into the question. So the question I have here is from Leetcode, which is with the name maximum subarray. You can also try it yourself. So the question here says that given an integer array nums, find the subarray with the largest sum and return its sum. Now before getting into the question, we need to understand what a subarray means. So they've also provided the definition here. A subarray is a contiguous non-empty sequence of elements within an array. What this means that whenever we have an array and any contiguous block of elements within that array can be a subarray if it is non-empty and it is contiguous. So for example, I have this array here. So in this, -2 is a subarray because it is non-empty, plus it is only one element, so it is contiguous in itself. -2 1 is a subarray because it is contiguous as well as non-empty. Similarly, -2 1 -3 is a subarray, -3 4 -1 2 is a subarray, as well as this entire array is also a subarray. So now that we know what a subarray is, let's start with the question. So the question says that you have to find a largest sum subarray within an array and you also need to return its sum. So I have my first input here. So in this one, if we try to look at each element and if we try to find out each subarray, we have to return the subarray with the maximum sum. Now what will be the first intuition or the first thought that comes to your mind after looking at this array? What can we do? How will we find out the maximum sum? The first thing that we need to do is, of course, find all the subarrays, correct? And then find sum of all the subarrays and then return the maximum sum out of it. Return the maximum sum out of all the sums that you have calculated. Okay, this is how we are going to solve this problem. The first intuition, the first thought. Now if we look at it carefully, if we are to find out all the subarrays in an array, what will the time complexity be? So how will we find out the subarray? The most easiest way is to pick an element and then treat it as the starting point and then iterate over all the other elements that we have, each time adding a new element, creating a new subarray. So for example, if I start with -2, then all the possible subarrays for -2 would be -2, then -2 1, then -2 1 -3, then -2 1 -3 4, then -2 1 -3 4 -1, and all the way until the last element that we reach. Again, for finding all the subarrays from 1, I'll start with 1, then 1 -3, then 1 -3 4, then 1 -3 4 -1, and this goes on. So for this we will need two loops, one that will be running outside on each element and one that will be calculating all the subarrays on the inside. So this definitely has a worse time complexity of big O of n square, which might not be feasible for this problem, because if you look at the limits, if you look at the length of the constraints, it is less than or equal to 10⁵. Now just imagine that if we write an algorithm which goes up to n square, then this will have a power of 10⁻10, which will definitely give us a TLE. Complexity in this case will be big O of n square and the space complexity would be big O of 1 because we are not using any extra space. So because we know now that this solution will not work, let's look at a more optimal approach, a more optimal solution. So coming to this question, I'll just copy the array here. Okay, so now that we have the array handy, let's start looking at the solution. So here if we look at this subarray, so for example, for the above approach, we were always finding a starting point and then generating all its subarrays and then calculating their sum. So again in the optimal one also, the starting point, let's say we take -2. Okay. So for -2, we now know that the maximum sum, or say the maximum sum that we need to find out, let's say we don't know this yet. Okay. And let's take one more sum, that is the current sum. Okay. So the current sum that we have. So for all the subarrays in the previous approach, we were calculating a sum, right? So that sum we can call as the current sum, and our result sum that we are to return, let's call it the max sum. Okay. So now that we have -2 here, what is the current sum? The current maximum sum that we have, that will be -2, because this is the only subarray, correct? Now if we want to say, like, let's take 1 also. Okay. And then we say the subarray now that we are considering is -2 and 1 both. Then in this case, what would be the sum of this subarray? It will be -1. Okay. And but also there's one more thing, that if we consider 1 as a separate subarray, then what will be the maximum sum? 1. And 1 here is even greater than the total sum of this subarray, right? That is -2 plus 1, which was -1. But if we just consider 1 as the only element, as the only subarray, then we get a sum of 1. Okay. Now 1 is greater than -1. So what should we consider as the current sum? Should we be considering -1 or should we consider 1? We'll definitely consider 1, because we have a maximum sum, right? Until this point, we do have a maximum sum. Where we are excluding -2. We are only considering this subarray. We are not considering this subarray in total. Now, if we look at -3 again. So, what does this total subarray sum is? -2 plus 1, -1 minus 3. It is -4. And if we are checking only from 1, what the sum will be? The sum will be -2, correct? For 1 and -3. If you are only looking at -3, the answer will be -3, because it's the only subarray, the only element in the subarray. So we have these 3 possible combinations. We have -4, we have -2, we have -3. Now we have our current sum as 1. As soon as we find a sum, so for example, if we say the maximum sum, if we initialize it with int min. So the int min is actually the lowest integer value possible for an int. Okay, the lowest integer value which is possible for an int. Let's just initialize our maximum sum by this, because even if we find any sum which is greater than this value, that can be treated as our maximum sum. So let's just initialize it with int min, and then now here we have a 1 here. So our 1 is definitely greater than this value. So that being said, when we are traversing the array for this until this point, I already have a maximum sum which is 1. And then we have, when we are considering -3, we have -4, -2 and -3. Okay. So in all these 3 sums that we calculated, do we have anything which is greater than our maximum sum, or which is greater than our current sum? We don't have it, right? Because all these values are negative. We don't have anything greater than the current sum. And if we don't have anything greater than the current sum, we definitely don't have anything greater than the maximum sum. So what will we do here? Whatever we add to this current sum, it's always going to add or contribute a negative factor or a negative number. So what we'll do, we can just say, you know what, sum until this point, let's call it 0, because if we add anything to the current sum right now, anything from these values, even if you add a minus 2, which is the least of all, or which is the maximum sum out of all, then to what this value would be? It would be minus 1. Is this contributing anything to your 1? No, right? Even if you find anything very positive or a greater positive number in the rest of the array or in the rest of the sub array that you are treating as, then also this minus 1 will contribute as a negative only, and it will lower your sum. So we don't need this. We'll just say when we reach at this point, we are finding a negative value, and anything later on that we find positive, if we add it with this negative value, we are going to get a decrement. So we'll just say that at this point, let's just treat it as 0. And then again we start with the next element, that is 4. The 4 here is very positive, so if we add 4 to it, the answer now we get is 4. Okay, after we get a 4, we move on. Now this 4 is maximum than our maximum sum, so we'll just update our maximum sum to 4. And then again we have a minus 1. So what we will do with this minus 1? Now we have 4 plus minus 1, that is 4 minus 1. So the current sum that we have will be 3. Okay, now here one question might arise, that like previously how we took after 1 there was a minus 1 and we did not take it because that was lesser than our maximum sum, as well as it would add as a negative number to our newer sum, or to our existing sum, or to the next sum that we are going to find. But in this case, when it comes to 3, when we are doing 4 minus 1 and it comes to 3, we will replace 4 by 3. And why we are doing it? Because in the later part of the array, or in the later part of the sub array, we might find a sum which will add up to this value and will produce a greater sum than this maximum sum. So for example, here if we see 2, so we'll just add 2 to this and we'll get 5, and then we have a 1, so we'll just add 6, and then we have a minus 5 again, and before applying this minus 5, we will just update the maximum sum to 6, and then we have a minus 5. So what are we going to do? 6 minus 5, this is 1. We will still replace our current sum with 1. Why? Because this is not a negative number. And even if we find something in the later part, this is only going to contribute as a positive number and not as a negative number. So the value is only going to increment. It is never going to decrement. So we will just replace it with 1. And then we reach a 4, and that will give us 1 plus 4, that is 5. And since this is still less than maximum sum, we now reached a sub array. Which is going to give us the maximum sum, which is 6. And as you can see here, the largest sub array, that is the largest sum, is 4 minus 1, 2 and 1, which is 4 minus 1, 2 and 1. Now running through this array, or running through this approach, what is one thing that comes to your mind is, at every given point or element in an array, we have two choices to make: whether to add the element, or the sum resulting from the element to the current sum, or not. So here I just want you to observe one thing, that if after, for example, let's take the minus 2 and 1 situation only. So after this point, I have the maximum sum as the 1. But if I encounter a minus 3, should I choose this minus 3 or should I leave it? So the answer to this is, even if your current sum until this point would be would be 1, and then you are encountering a minus 3, the current sum will become minus 2, and the minus 2 here is not going to contribute anything to the result, to the next array or the next elements that we are going to traverse, the next sum that we are going to get. It's only going to add a negative value. So anything, any part or any subarray that has a sum resulting in a negative value, not even 0, negative value, should not be added to the upcoming result, because this will not have any effect on it. It will actually have a decremental effect on it, and our sum will actually go down. So this brings us to an approach where we will be using two variables, one being maximum sum as I mentioned, and the other being the current sum. So what you're going to do here, the maximum sum you will initialize with int min, and the current sum you can either initialize by a 0 or you can initialize it with the first element that you have. And then after that you start traversing this entire array. Each time if you get a sum, so for example, let's say you're writing a for, okay, and here you will go until the array dot size. The for will start from 0 and will keep iterating until you reach the end. And inside this, if you just keep incrementing the current sum to whatever array element you will be traversing currently. And if there comes a situation where your current sum will actually be less than 0, then you will not update it to your current sum. You will directly update your current sum to 0, because the value until that subarray is simply going to be 0. We are not going to need it. That is of no value to us. That will only decrement our value. And then at each point we will say that, you know what, update the maximum sum to the max of maximum sum and the current sum that you have right now. Otherwise, if it's not a negative value, then definitely the current sum will be updated with that value, and that will give us this is the pseudo code, and we will just return the maximum sum. Okay, now let's get to the code. We'll solve this question on the Leetcode platform itself. Now, starting with the solution, we will need two variables. So what we can do in this case, we can also initialize maximum with the first element that we have, and then we'll also need a current sum variable, which also we can initialize with the first number. And then we'll start a for loop which runs from 1 and which will go up to nums.size, because this is a vector, so we'll be using nums.size. And then inside this we'll just check if current sum is less than 0, then we will just set the current sum as 0. Now why we are checking at this point itself without adding anything? Because here we have initialized the current sum as the first element of the array. And why we are doing this? Because in case we have all the negative elements in an array and the first element is the maximum negative, say the maximum sum negative, then we can directly return this answer. And then we will just add our existing element to the current sum value. Current sum nums is equal to nums of I, and then we will check if, or let's just say max sum is equal to max maxsum and current sum, and then we'll get out of this loop and we will just return the maxsum value. So let's just run it on the test cases that we have. Okay, so it got accepted in all the values. So for this case also, if we add just a -1 here, so I'll just add one more test case, and let's see, I'll say -1, -2 and -5. So the maximum sum here would be -1. I'll just run, and that works fine. Let's just try to submit it, and it got accepted. So talking about the time complexity of this approach, since we are only traversing the array once, so our time complexity for this will be big O of n, where n is the size of the array, and our space complexity would be big O of 1, because we are only using constant space. So yeah, that's all for the Kadane's algorithm. Do let me know how you like it, and yeah, I'll meet you in the next video. Bye bye.